Hello viewers, Wagadaruna taking you through the story of A-level applied mathematics. And this video we are going to go through the marking guide for Senior 5 Math Part 2, end of Term 1 for the year 2024. So this marking guide is for Mengo SS and is suitable for students in both Senior 5 and Senior 6 offering principal mathematics as part of their combination. So these are the papers we hope to upload in this Solid. So what is ticked is what is there on the platform, and today we are going to look at this paper. So for Mengo SS, there are two papers of applied mathematics, one having only mechanics and the other one with the rest of the parts, statistics and probability. So today we shall look at the one for the one for mechanics. Then the books you ought to get, there are 4 books in principal mathematics, that is Math Part 1, Math Part 2, Topical Question Bank, and Termly past papers with their marking guides. Subsidiary Math, it is only 1 book with notes, Termly past papers, and also UNEB past papers with marking guides. For physics, there are still 4 books, Physics Part 1, Physics Paper 2, Topical Question Bank, and its solutions. So if you need copies, contact the author on this contact. So just start with section A, which has 40 marks. Question 1 says, the resultant of the vectors this and this is this. Find the values of alpha and beta. So resultant means we shall add all the vectors and equate them to what is given as the resultant. So adding all this here, it should be equal to this. So we can collect now like terms. 2 alpha is here, 2 beta is here, then -1 plus 3 is 2, 2 plus 1 is 3, which is there. Then for the j components, beta is here, negative alpha is here, then 2 minus 7 is -5, -5 minus 4 is -9, which is here. So equating vectors, it means I components can be equated alone to give you this, which gives us equation 1. Then j components can also be equated alone to give us equation 2. Then we have to solve them simultaneously. Adding the 2 equations, you come up with 2 beta equal 2, implying that beta is 1. Then from equation 1, I substitute for beta to get alpha as 0. And that's what they wanted. Then question 2 says, two forces P and Q of magnitude 4 newtons and 25 newtons, 40 newtons and 25 newtons are inclined at an angle of 120 to each other. Find the magnitude of the resultant, so P plus Q means resultant, and its inclination to force Q. So there we have to make a sketch. Now, because they said they want the direction or inclination to force Q, it is advisable to make force Q the horizontal. Then you measure off 120 degrees to get force P. Now, when there are 2 angles inclined at an angle, the method to use is called parallelogram rule. So we are going to draw another force parallel to this here, and a force parallel to this here, to come up with our parallelogram. I think you realize that this and this are dotted. Why are they dotted? Because it is just a representation of this. If you make them full line, it means it is also a force on its own, which is not okay. Then from start to end gives you the resultant. So this is what they want, and this. So let's see how to get them. 1, I can use cosine rule to get this because I know this angle and I know the forces enclosing the angle. So magnitude will be equal to square root of 25 squared plus 40 squared minus 2 times 25 times 40 cos 60. Then use a calculator and get the value they want. They also want the inclination, which is this. For this, we can now use sine rule. So sine theta over 40 is equal to sine 60 over 35, which is here. Then make theta the subject, you come up with that as the inclination they wanted. So first diagram, it should be drawn with a ruler. Always remember that. Question 3. Two bodies are moving with velocities given by the vectors this and this. Find, Roman 1, the possible value of lambda if mu is 2.5 and the bodies are moving along perpendicular roads. So there they want you to remember the condition for perpendicular vectors. And the condition is that when you dot them, you get 0. So I'll come and dot the vectors. This times this to give you this. This times this to give you this. And this times this to give you this, equal to 0. Collect like terms, factorize, and get the two values of lambda. Then Roman 2, they said find the value of mu if the bodies are moving along parallel roads. So they want you to get the condition for parallel vectors. So for parallel vectors, one is a scalar multiple of the other. So k is a constant. Using the first row, we shall get lambda is equal to 2 lambda k, giving you k as 0.5. For the second row, lambda plus 1 is equal to k lambda, which is giving us lambda equal to -2. Then the third row, -4 lambda is equal to mu, implying that mu is 8. And that's what they wanted. Question 4 says a particle moves 6 meters in the direction south 65 degrees east, then 8 meters due north 35 degrees east. How far and in what direction is the particle then from its starting point? Now this one is similar to what you did in O-level. The only thing is that in O-level you used a graph paper, but here we expect you to use calculations. So you only sketch and use calculations. So you come and start drawing. At the starting point, the direction was south 65 degrees east, meaning this is 65 is here. For alternating angles, this is also 65. Then from this point, they said he moved 8 meters in the direction north 35 degrees east. So you come and locate our north 35 degrees east, which is here. And the distance is 8. So when you add these two, this plus this, you come up with 100. So the whole of this angle is 100. Then they said, how far and in what direction is the particle then from the starting point? Meaning, we are going to draw a straight line from start to end and let the distance be x, but they also want the direction, so you have to get beta. So to solve this triangle, you need to get an unknown angle inside. That's why you got the whole of this 100. Then I can use, if I know this with this and this with this, you see, this is unknown, this is unknown, so I can't use sine rule. Therefore, the option is to use cosine rule because I know this angle and I know the sides which enclose that angle. So I'll come here and say, by cosine rule, x will be equal to 6 squared plus 8 squared minus 2 times 6 times 8 equals 100, which is here. Use a calculator, you come up with the distance they wanted. Then for direction, we need to first get theta. Using sine rules, sine theta equal to 8. Sorry, sine theta over 8 is equal to sine 100 over x, which is 10.8014. Then make theta the subject, you come up with these angles at 2 decimal places. After getting theta, I remember that angles on a straight line add up to 180. So I can get beta, which will be equal to this. Therefore, the required direction is north, 68.16 degrees east. And that's what they wanted. So diagram should be drawn with a ruler. Question 5. The forces, two forces F1 and F2 of magnitudes 50 and 5 newtons act in the direction of the vectors this and this, respectively. Find the resultant of the forces. So one, we have to convert the forces in vector form. This is the force F1, its corresponding direction, force F2, its corresponding direction. So the formula is 1, you get the unit vector and multiply it with the magnitude of the force. So this is the unit vector multiplied by the magnitude of the force to get the force in vector form. So magnitude is this, magnitude of this direction is this, and the vector is there. You simplify to come up with that as the force in vector form. Do the same for force F2 and get also the corresponding force in vector form. Then the resultant will be got by adding. So it's under vector, that's why the force remained in vector form. And that's what they wanted. Then question 6 says, find the resultant of the vectors this and that, and hence show that the inclination of the resultant vector to A is about this. So because they want the inclination of the resultant to A, it means we have to get the angle between the resultant and the resultant vector and this vector A. So let's first get the resultant vector. Resultant vector is got by adding. When I add, I'll come up with this, which is vector C. Now the angle they want is between vector C and vector A. Therefore, I'll come and use dot product. A dot C is equal to magnitude of A, magnitude of C cos theta, where theta is the angle between the two. So this dot has to be visible. Then dot, okay, before we dot, let's see the marks for this slide. Addition, output, substitution. Then we have to simplify. When I dot, I'll come up with this, magnitude of this. So I can make theta the subject, and that will be the answer they wanted. But remember, they said about 79, so we have to round off to a whole number, which is the required angle. Then question 7, two forces R and T are such that this is equal to this and 3T is equal to negative 5R. If magnitude of T is equal to 65, find the possible values of M. So first of all, this is what we are given, and we are given R, so come and substitute for R. Then make T the subject. After that, you can get the magnitude and equate to 65. Magnitude is given by that, equate to 65. Simplify to get that. So the whole of this, okay, 65 divided by 5 over 3 gives you 39. Then square both sides, make M the subject, and that's what they wanted. So now shall go to question 8. It says two bodies A and B are moving with velocities of magnitudes 60 kilometers per hour and 37.5 kilometers per hour respectively along roads which are inclined at 120 degrees to each other. If these bodies are moving towards a common point, find the magnitude and direction of their resultant vector. So you shall have one 60 degrees, 60 kilometers per hour, and the other is 37.5, but the angle between them is 120 degrees. So because there are two angles inclined, two forces, okay, two velocities inclined with an angle between them, it implies that we need to use parallelogram for us to get the resultant velocity. So reproduce this here and reproduce this side. But remember, they must be dotted. They must be dotted. Then the resultant will be that the direction matters. Okay, so now I can use cosine rule to get the value of v, because here with this v I know this angle and the velocity which enclose the angle. So the velocity will be that. Then by sine rule, sine theta over 37 is equal to sine 60 over 52.5. Then you make theta the subject, and that's what they wanted. That was section A. Now we shall go to section B. So question 9 says, the table below shows the magnitudes of concurrent forces and their corresponding directions given as bearing. So the entire trick was on this word bearing. Bearing. Why? Because we all know that from trigonometry, positive angles are measured from horizontal going in an anti-clockwise direction. But when they put bearing, it is a little funny. Do you know why? Because bearings are measured from the north and going in a clockwise direction. And those will be the positive bearings. So that was the main trick which made candidates misfire. And if you can't realize that, it means all the 12 marks will go. So for example, in trigonometry, if I want to measure 180, I would have gone from here and measure up to here. But because there is the word bearing, it means I have to measure from here up to here. Like that. So bearings, you start from the north and you move in a clockwise direction. So write each of the forces in the form HG. So what we know that for in column, so in this case, because the angle is lying on the vertical, it means that the vertical will have cos and the horizontal will have sine. So for example, this one, your work is to just say 34 sine 180 degrees as the horizontal, and then 34 cos 180 degrees as the vertical. As simple as that. So let's do that for all the forces. So force A, like I said, you begin with sine, then cos. Use a calculator to get that. Then this one also sine, cos. Use a calculator to get that. This one also sine, cos. Use a calculator to get that. This one also sine, cos. Use a calculator to get that. This one also sine, cos. Get that. And lastly, sine, cos. Get that. So basically, that is what they wanted in this question. So each force had 1 mark. Then part B says, Hence, find the magnitude and direction of the resultant of these forces. So magnitude, first of all, the resultant vector is got by adding all the force vectors. When you add, you'll come up with this as the resultant. So you can either write in SID form or in decimals, but decimals should be 4 decimal places and above. So magnitude will be this. Then the direction, we shall first sketch negative horizontal and negative vertical. Then the resultant is from the start to end, and the direction is theta. So using SOHCAHTOA, I can get the value of theta, which is 24.55. Therefore, the bearing will be, remember we said the bearing will start from north, so it has to be from here up to here, which will be 270 minus this to give you this as the direction they wanted. So now we shall go to question 10. Question 10 says, a force F is the resultant of the forces X and Y. That means that F is equal to X plus Y, which are inclined at an angle theta to each other. Okay, part A. If the magnitude is 9.6 and magnitude of force X is 14, magnitude of force Y is 22.4. Find the value of theta, and also which is the inclination angle between the two forces, and the inclination of force F to force X. Meaning when you're sketching, X is better when X is on the horizontal. Then 2, you realize that the resultant is smaller than any of these two. When that happens, it means that this inclination is obtuse. So when you're making our sketch, we shall come and draw a parallelogram such that the inclination is obtuse. That is force X, then force Y. Then that means we need to complete our parallelogram with dotted forces and then draw our resultant. Okay, so the question wants the value of theta. So you come and say that by cosine rule, this is equal to this squared plus this squared minus this times this cos 180 minus theta, which is this. Then we shall simplify and see how to get the value of theta. So cos 180 minus theta is that, 180 minus theta is that, meaning that theta will be 164.92. That was part A, Roman 1. Roman 2, they want the inclination of force F to X. So they want angle beta. For that, we can use sine rule. Sine that is equal to that, and sine this is equal to sine beta over 22.4 is equal to sine this over 9.6. Simplify and make beta the subject. And that's what they wanted. Then for part B, they said if X is equal to this and Y is equal to this, and F acts due northwest, find the value of N and the magnitude of F. So remember, F was the resultant of X and Y. So when I get the resultant, I'll come up with this. But the direction of northwest means that the inclination is 45. So you'll come here and say that tan 45 is equal to that over that. Tan 45 is 1. So cross multiply to get that, correct like terms, and get the value of n. And that's what they wanted. Then Roman 2, they want the magnitude of f. So now that we have got the value of n, we can get the vector form of f and also get its magnitude later. So substitute n here. We'll come up with that. Then magnitude will be that. And that's what they wanted. So that brings us to the end of this video. Thanks for watching, and be reminded the next video will be on end of term 1 senior 5 math 1 for Nalia Secondary School. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video has been uploaded. And also, if you know any student who is not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp, so you can all benefit